Let's start. I mean, what can I say, right? C and C++ are inherently unsafe. And it's not me saying that, right? That's Bjarne Strostrup, Professor Bjarne Strostrup, the father of C++. And excuse me, I have this tiny technical glitch. Here we go. Okay, cool. And sure, C is worse because in C I can do stuff like, I don't know, assign to a const. It's a constant, but you can still assign to it. And it's not working for some reason. Why is it not working? Every talk must have a bug. I hope this is the bug of this talk and we'll get rid of it. Okay, and this is... Yeah, my fault. You're absolutely right. So, you can assign to a const. And what's going to happen? You'll get away with a warning, which you will ignore. Not you, I mean, you are experienced, expert C and C++ developers, but there are other developers, and they don't pay attention to warnings. And C++ is indeed safer, because if I try to assign to a const, if I try this very code, I'll get a compilation error. So I won't be able to run this code, right? So I can't assign to a const in C++, and it's safer. And it came up with this strange mechanism called constcast, which was designed specifically to circumvent this very safety mechanism that we just talked about. So what's up with you, C++? Conclusion. Don't do C. Don't do C++. Learn Rust. Vibe coding. That's a safe route to choose, right? Thank you for attending my talk. Have a nice rest of the day. Thank you. No applause. Okay. No applause? Okay, so I'll continue. Because since you're here, you're probably using C and C++, right? Maybe both. And we have to deal with that, right? We have to come back home with all our limbs intact. And maybe I can help. Maybe I can help you avoid shooting yourself in the foot or stepping on a landmine and blowing your whole leg off and stuff like that. Most of the things I'm going to talk about is for both C and C++. Some examples will be C-specific or C++ specific. Please don't throw laptops at me. Thank you. And I'll start with something that both Bjarne Strostrup and Dennis Ritchie, the father of C, had in mind, but they didn't tell you. It's like an implicit assumption about, about you guys, that you are responsible adults. The fact that you can assign to a const doesn't mean that you should. Or if I may quote another celebrity, that's my personal Uncle Benjamin, with great power comes great responsibility, yes. And with that, let's see what kind of minds we're actually talking about. So, I'm going to talk about stuff that is specific to C and C++. There are lots of dangers in the world, but I'm going to talk about two of them. One of them is that, as I said, both languages are unsafe. Okay, like memory safety and stuff like that. Okay, and that's scary. But that's not all, because both languages are also unpredictable. And that's cause for panic. So let's start with safety, because that's just scary, right? And I'm going to show an example, but I hope that nobody here has a heart condition or blood pressure issues, because this is going to be scary. Ready? Boo. This is innocent, right? But this seemingly innocent piece of code is responsible for some of the worst security vulnerabilities ever. And I'm talking, of course, about, altogether now, buffer overflow, yes. And that is indeed scary, right? And this is the danger that I'm talking about, okay? Not just bugs. We can have bugs in any language. You need a specially crafted language to have this kind of bugs. And by the way, I'm going to talk about safety, security, more or less interchangeably throughout this lecture. There are definitions of safety and security. Some of them contradict, some of them overlap. I don't care, okay? For this lecture, safety, security, more or less, same thing. Okay, so what kind of safety issues we have with C and C++? Let's talk about lifetime safety, like using an object after we deallocated it. Bound safety, do not use an array at -3. C++ people do not use a vector at size plus 3000 or so. Type checking, casting, thread safety, that we have in other languages as well, like data races and all these deadlocks and cool things like that. And of course, no matter how much you plan, no plan withstands the rigors of the runtime. Okay. And the fun thing is that you can mix and match. You can have combinations like, I don't know, thread and lifetime. You use an object in one thread while you deallocate it in another. That's fun, right? But that's not all, because as I said, C and C++ are very unpredictable. And you have another name for it. You probably know it as UB, undefined behavior. But undefined behavior is just the tip of the iceberg. It's just part of the problem. Yes, there is undefined behavior, and the meaning of undefined behavior is where the standard itself of C or C++ tells you anything goes. Whatever happens now, it's good. It's official. It's supposed to happen. It's fine. Classic example, division by 0, right? If during runtime the denominator happens to be 0, result can be 0, int min, 5 on Thursdays, and format your hard drive and whenever it feels like it. And that's fine. If your compiler launches nuclear missile attack when you divide by 0 during runtime, it's a certified C and C++ compiler. That's totally fine. You know the image of the dog with the flaming house around him? That's fine, really. I hope you're not using these languages. They're... Let's talk about that later, because we also have unspecified behavior, and that's totally different. You know what? I'll explain that with an example right away. Okay, so we have function f. It receives x, y, and z as parameters, but instead of sending 1, 2, 3, I'm going to call functions a, b, and c, take their return values and pass them as arguments. Okay? So the standard says that a, b, and c will be called, and their values will be passed, but which one will be called first? Will we call A, then B, then C, or C, then B, then A? And you don't have to answer because you can't answer. Because any of the 6 permutations, including the ones where the B is the first one, okay, any of them are valid. Even worse, if you call f twice, it can call the functions in a different order. It can, throw a random function in order to determine which one is called first. So I really hope you're not counting on the order of execution in these cases, okay? That's unspecified behavior. A, B, and C will be called. The standard tells us that they will be called, but in which order, that changes Anything goes. Okay, and then we have stuff like implementation-defined behavior. That's a behavior that is defined. It's okay by the implementation. So it's compiler-specific. Classic example, size off. What's the size of long on your system? The one you're using right now. The last one you used yesterday. 8. Okay, 8, that's 64 bits, okay? 32 bits. Do I hear 128? 128 going once, going twice. Yeah, it's like a bid, right? Because it can be anything, but at least if you have a specific compiler on a specific operating system, a specific bitness on a CPU, and it gives you an answer, that's going to be consistent. So it's consistent within the implementation. Okay, but there's more. We have stuff like conditionally supported behavior. Pragma, hashtag Pragma. Okay, some compilers support this, some compilers support that, etc. We have locale-specific behavior. That's about languages. And as a Hebrew speaker whose language is both extended ASCII and right to left, I can just stand here all day and talk about that. So I won't. Instead, I'll say something not nice about C, because I didn't say anything until now, right? So it's all C's fault. C started it, okay? Dennis Ritchie, this is on you. And he had good reasons, okay? But C started it, and C++ just, inherited it. See what I did there? And then added classes and templates and all that. So C started it, but at least, now I'm going to say something bad about C++ to make it balanced. C, at least, after reading the whole standard that is filled with unspecified behavior there and undefined behavior here and all that, at least at the end you have this appendix, this annex, where you have a concentrated list of all unspecified behaviors with references to the pages. And then a list of all the undefined behaviors, et cetera, et cetera, et cetera. So at least you have a checklist that you can check your code against and see if you did something stupid. And C++ doesn't have that. I don't know why, but it doesn't have this annex. And if you know someone from the C++ standard body, please tell them that I am begging them to add this annex. Okay, C++ 26 or 29 or etc. Okay, so C and C++ are complex, unsafe, unpredictable. But I have good news, people. There is an answer. Yes, there is. It's a simple one, and you're not going to like it. Because the answer is migrate. Run away, move, change, switch to another language. I told you to learn Rust or vibe coding, right? But again, don't get stressed, don't fret. I'm the bearer of good news because, before that, let's talk about who wants us to migrate, because it's not me, right? It's all these acronyms. It's the US government, basically. Did you read all these publications in the last 2-3 years? They're urging us to move away, to stop using C and C++ by 2024, then 2025. Then they said that by 2030, we must at least have a plan to migrate away and stop. Yeah, that's funny, right? And stop using C and C++ in mission-critical applications. But as I said, I'm the bearer of good news, and it's just not going to happen. It's not practical. I mean, just look at the amount of existing code base that we have. If by 2030 we're supposed to finish migrating Linux totally into Rust or something, and Windows, and all these other pieces of code running all kinds of software, and we're not allowed to run C++ in mission-critical applications, then by 2030, you won't be able to ride a car, or an airplane, or a ship, or use any medical device, because everything out there is filled with C and C++, okay? And it's not only the huge code base. We also have an ecosystem. We have libraries. We have tools, okay? Stuff that is C and C++ specific, or stuff that has requirements that we can't implement that in any other language, okay? So there's this ecosystem that you'll have to migrate as well and recreate in some other language. And you know what's another part of the ecosystem? You, okay? You are, as I've been told, experienced and expert C and C++ developers. And you're not going to become expert and experienced whatever else developers just, overnight, okay? And then we have requirements. If the requirements are for real time, then of course we can't use managed languages like Java and C#, right? And if the requirements are for efficiency, then JavaScript, Python, bye. And if we need low-level access, then Rust, that's the way out. And the list goes on. And the thing is that there's really no alternative. The only alternative to C is C++. The only alternative to C++ is C. Yes, there is assembly, and I'm not going to finish this sentence. Okay. So this is probably not the answer. So what is? Well, it turns out that if there's no magical answer, it must be hard work. And we need all kinds of solutions to deal with the fact that we do have to use C and C++. And it starts with standardization. C++ is a safer version of C. We have in the standard, instead of the almighty C cast, we have 4 weaker ones. Instead of using raw pointers, we have smart pointers, etc., etc. There are also other initiatives to make C++, especially C++, safer, stuff like Safe C++. Have you heard of it? Sean Baxter's safecpp.org. Take a read. It's very interesting. It's like adding stuff to the standard or adding extensions that make C++ safer. And there are international standards when you write commercial software, stuff like the International Standard Organization, ISO 26262, nicknamed FUSA, functional safety in road vehicles. That's a standard that deals with safety, mechanical safety, electrical safety, and yes, software safety in road vehicles. But anyone familiar with FUSA? Okay, maybe you pronounce it FUSA or something, I don't know. Or FASA, I don't know. The thing is that it's more about, it's high level. It deals with the process. It has stuff like all requirements must be fully documented. Okay, it doesn't have like, what I need is like lower level. I need coding practices. So we have those as well. OWASP, anyone heard of OWASP Top 10? Okay, it's a list of things to consider, things to think about, like always have logging and telemetry, okay? Authorization, authentication, maybe you need that, maybe not. But even if you go through all the 10 items there's nothing specific to C and C++, and as we saw, they need special attention. So OWASP is not what I'm looking for. There are, like more of ways of thinking, like defensive programming. Who's familiar with that? Ooh, very few people. Okay. Defensive programming is stuff like design for the worst, plan for the worst, trust no one. Okay, always expect the input to be invalid, so check for it. First thing you do in a function, check the input. Okay, don't trust anyone. The fact that you asked people to pass a valid pointer doesn't mean that they won't pass null or whatever. And it seems like a paranoid approach, and it is. But you know, the fact that you are paranoid doesn't mean that the runtime is not out there to get you. So defensive programming is a good way of thinking, even if it is paranoid. And then we have initiatives like the Secure by Design initiative, or maybe I should call it Secures by Design's initiatives, because there are several with the same name. One of them is by all the initials we saw earlier, the US government. So CISA, one of the offices, has the Secure by Design initiative. Google has its own paper titled Secure by Design, and this is how they're supposed to at least write code in Google, C and C++ code specifically. And we can see all kinds of ways how to design your code to be secure from the get-go, from the design phase, even if in, for example, Microsoft SDL, Security Development Lifecycle. So there is that. But, you know, I'm looking at this list, and it's, I mean, I can give programmers the whole list and let them read it for a month. And then what? What I need is, how do you say it? In Hebrew, we have a word, tachlis. It's, let's get down to it, like boots on the ground, like, you know, yeah, enforcement. Cool. So we need enforcement. And for that, we need a two-pronged attack. We need a scissor maneuver, okay? Scissors maneuver, like from the left and the right. So one side will be to have a set of rules, do's and don'ts. For example, do not use void pointers, always have type pointers, okay? And having rules is nice, but then, again, we need to enforce them, and then we need tools. And we have quite a few rules. It started with, for example, the JSF C++ standard that was used to develop software for the JSF fighter. You now know it as the F-35, probably, okay? And then we have SciSec and MISRA and AutoSAR, and I could go on. And they're all a set of guidelines of do's and don'ts, and they're very nice. But then we need tools. And luckily for us, we already have them, and you're already using them, I hope. Static analysis tools, okay? So I can tell my static analysis tool, look for void pointer and alert me whenever you see it, okay? So these are a good pair. And I'm going to talk about a specific set of rules called MISRA. How many of you heard of it? So why did you come to this lecture for? I don't know. Okay, so I'll talk about MISRA. It's one of the most popular ones, and now I have proof for that. And like 2 years ago, more or less, it merged with AutoSAR, so now it's even more popular. And I'm going to, you know what? Let's start with an introduction. Let's start with introducing the Motor Industry Software Reliability Association. And my apologies, I should have said that with a British accent, not with my terrible Israeli accent, because this is a British association of motor industry. That for Americans here, that's the automotive industry. For everyone else, that's car makers, okay? So motor industry, British motor industry and academia created this association, and they came up with these guidelines, first for C, then for C++, Then it was aimed at the motor industry, of course, but then the aerospace industry saw that and adopted it, and then the defense industry, and then medical and industrial, et cetera, et cetera. And then other industries, like other companies, for example, BMW, a German automaker, is now part of MISRA as well. Okay, so now it's international and it's not just cars, it's everywhere. And I'm going to show you examples from the MISRA C++ specification. Okay? Don't throw any laptops, mice, whatever, please. Latest one is from 2023, and okay, the C people here are starting to fall asleep, so let's do it like this. Okay. C people, no, C++ people, okay, listen to me. Latest release 2 years ago, 2023, it covers up to C++ 17. Yes, that's not the latest and greatest, it's not C++ 23, but not many people use 23. In production, anyone here using C++ 23 in production? Wow, okay, very brave. I personally know a few companies who are still contemplating the move to this new and dangerous thing called C++ 11. So 17 is fine. And it has 179 guidelines of, do's and don'ts. And it seems like a lot until you think about the fact that the standard is almost 2,000 pages long. So 179 is a very small number. On the other corner, we have Mr. C, and it released its latest and greatest a few months ago. So it's 2025. And it covers up to C17, which was released in 18, and I'm not going to get into that. And it has 223 guidelines, which is much more, but then again, we saw that C is less safe than C++, so it probably needs more guidelines, more guardrails. You know what? Let's dive right in and see an example. Okay, so before I get into the rule itself, I want to talk about the peripherals to show you how much thought was put into this. So first of all, on the left, you see that I'm talking about guidelines, but this is a rule, so there are rules and there are directives. I'm not going to go into details here. What I would like to talk about is categories, because we have mandatory, we have required, and we have advisory. And that's interesting. I mean, mandatory means, okay, you must obey this rule, no alternative. And advisory is, this is my suggestion, do whatever you want, it's your funeral, go ahead. And required is the interesting one, because in required, you should follow and adhere to the rule, to the guideline, or if you feel that you really have to, you can deviate, but you have to fully and formally document each deviation and violation of the guideline. So now you have a choice. You wrote this line of code that you are in love with. We're all in love with our code, right? So I wrote this line of code and I'm in love with it and I can keep it. But now I have to write this very long and detailed document about why I must keep this line of code. So I can either spend my time writing this document or just fixing that line of code and get on with my life. My choice. Okay? So this is very smart, I think. And we also have something called decidability. Decidability is very interesting because a decidable guideline means that a static analysis tool, we can show him the code and tell it, does this code comply with that guideline? It's that simple. And 80% of the guidelines are decidable, which means that most of the MISRA guidelines, we can let static analysis tool, automatic tools, do our job for us, which is nice. And we also have scope. That's the single translation unit versus system scope. Okay, how much code we need to read in order to realize what this rule is about. You know what? So let's talk about the rule itself. May I introduce to you Rule 942. The structure of a switch statement shall be appropriate. Any questions? What's the color of the tie, you mean, right? What does it mean, appropriate? And this is decidable? I mean, what is the static analysis supposed to do with that? Yeah, well, I was hiding information from you, of course, because every guideline has an amplification and rationale and code samples. Okay, you're not alone here. And the amplification tells you exactly what appropriate means in this context. And in this context, a switch statement is structured appropriately when it conforms to the following restrictions. And you have a list of restrictions. Okay, so for example, number 7, every switch statement shall have a default label. Okay, and now a static analysis tool can go and look for all the switch codes that I have and make sure that they have a default label. Easy. And that also makes sense because, you know, I don't want my code to fall through a switch statement just because I forgot a case. So default will catch all my forgetfulness. But there is a problem here. Oh, I know what the problem is. It's the very first rule. Rule 001. They have a great numbering convention. A function shall not contain unreachable statements. Can you see the contradiction? The collision here between the rules? This contradiction has a name. Enumeration. Because when I have an enumeration, so I do a switch on it, naturally, right? And I have case this, case that, and that's it. I only have this and that. So according to the last guideline, I must write a default statement, right? To cover, I don't know, all the bases. But according to this one, a function should not contain unreachable statement. And default is definitely unreachable because I only have this and that. Again, you can't trust me. There is an amplification, of course. In this context, a statement is unreachable if the block containing it is not reachable from the CFG, etc., etc. I'll make it simple. We're not talking about logical unreachability, if that's a word. It's not about, well, it's an enum and I covered all the options, so we'll never get to default. It's stuff like I'm writing lines of code after the return statement. That's unreachable in this context. Okay? So as you can see, the MISRA guidelines contain some contradictions, sometimes even overlaps, but it's only superficial. When you dig in, then you see that each one comes with its very good reason. Okay, so a lot of thought was put into this. And by the way, maybe I should have said that up front. I'm not a member of MISRA. I don't have any shares. I don't know if they have any. I'm not getting a dime out of this. I just think that MISRA is a good way of thinking, and I think we should all be using it. Okay, let's talk about tools. So, as I told you, static analysis tools, which you probably already have and use and love or hate or both. Yeah, I guess it's both, right? So most of them already have a rule set that you can configure and let your static analysis tool look for MISRA guideline violations. Okay, so if you're using Clockwork or Clang Tidy or what's its name? Sonar, right. So if you're using one of those, then you already can tell it to track MISRA violations. And here we can see the unreachable statement rule in action. And you can see here that it's using the MISRA rule set. Okay, so now there is a problem, which is, up until now, I had to be a language lawyer. You know what a language lawyer is? Okay, that's where when you have to, in order to be a good programmer, or any programmer, you have to know the standard by heart, in and out, all these small details and intricacies and all that. And with C++, it's all, you know, all these corners of the language, and C as well, yeah? So I had to be a language lawyer with C and C++. And now I need to be not only that, but also a MISRA lawyer? I mean, why would I do that? And you can read this because I'm not going to talk about this. This is something that I prepared for you to try to persuade you to use MISRA, why it's a good thing. You know, working software is better than just writing code. You don't need more code, you need better code. And it promotes safety and portability and predictability and all these things. But I'm not going to talk about that because I've been hearing what you were thinking here. You were thinking it too loudly, at least some of you. And what at least some of you were thinking is, great, like another rule book to limit my creativity, right? We are developers. We have a soft heart. We like to write software. We like to express ourselves. And now there is all this limitation. And I felt that too, at first, but the right mindset, I think, is to think about it differently. Not about restriction, it's more about predictability, okay? Writing predictable code, okay? And when you avoid all these dark corners of the language, you get code that is easier to reason about, to maintain, to review, to audit, to write eventually. Okay, and this is what MISRA and all the other rule sets are really about. This is why we need guidelines. Yep, I said it once and I'll say it again. C and C++ are inherently unsafe. They have lots of smoking guns and buried landmines in the form of unsafety and unpredictable behavior. And there is no alternative. And there is no magic bullet or solution. But there are ways to mitigate the problem. And having a set of guidelines to follow and tools that will enforce it is the way to go. And specifically, using rules sets like MISRA C and MISRA C++ will help you and your code be more safe and more predictable. My name is Assaf Tzur-El. And I've been programming and architecting and CTOing, if that's a word, for the last 30 years. And in the last 15 years, I've been also teaching courses and training and all that. And basically, I love to help. This is what I do. Specifically, I love to help people and companies who want to change the world through technology. That's my goal. That's my mission in life. And I hope I helped you today to keep your limbs intact, not step on landmines or shoot yourself in the foot. And if you need help, if I can help in anything, if I can help you change the world, let me know. Thank you. Questions?
Have you been following the honest Strips work on C++ safety? Because it's a lot better now.
Yeah, okay. No, I haven't actually. But,
watch his presentations on YouTube and look at the C++ core guidelines.
Okay, yeah, the C++ core guidelines, I looked them up. They're up to date. If the year now is 2017, I think. That was the last time. At least on GitHub.
No, it's not. It's
It's
gone
not?
already. It's 20.
Okay, 20.
Yeah.
Oh,
It wasn't
20.
23 yet, but 20 for sure.
No, I mean, the last date on GitHub is 2017 or so, but maybe later. Okay, I don't know. I'll check. But last time I checked, it was a few months ago. It was like, way back.
Well, you don't need a lot more from C++ to make it reasonably safe than C++ 17. C++ 20 helps. C++ 26 eliminates a lot of undefined behavior.
Mm-hmm.
In C++ 20, a lot of my unit tests run at compile time,
Okay.
and there is no undefined behavior at compile time. The compiler is required to flag everything, which is
Okay.
pretty cool.
Yeah, that's cool. Okay, what happens with existing code base? So you have to run it through the new compiler as well.
Well,
Right.
if you want the new
And then
version
it's
of
right,
the
yeah.
language, yes.
Okay, cool. Oh, that's a good thing to have.
But as a keyword, there are keywords for doing things at compile time,
Okay,
and the rule there is undefined behavior must be flagged by the
Flagged.
compiler.
yeah, cool.
It is.
Okay, yeah. So this whole MISRA thing is now history? We don't need that anymore?
I think Client Tidy implements those also together with the C++ core guidelines. So for instance, you cannot just take a vector and index it with a variable. Client Tidy will say this must either be constant or you should use .at or some way to check it.
But client tidy uses
Implements
constant rules, right? So
Yeah,
it's
there's
relying on.
books of rules you can enable.
So again, so it's using a rule set.
Yeah.
So we're back to this because it's not using the standard as its guideline, as its Bible. It uses a rule set.
Yeah, this is layered on top.
Right.
Because
Yeah. So this
safety
is
should not cost you anything at all at runtime.
right. Yeah. But this is what I was talking about. So all these static analysis tools do help you.
Yep.
So yeah, it's part of the static analysis tools job, not the language. Yeah.
At the moment, I'm looking at C23 as a Unicode support for identifiers.
Mm-hmm.
And you mentioned Hebrew, and I see a lot of danger in the homoglyphs, which you can have a multiple values. You can actually code it as two identifiers that look the same visually, but are two different.
Yeah.
What do you think about this? And also, in an ASCII-dominated world for a long time, now we maybe go to the multipolar world with maybe developments going eastwards, who knows?
Mm-hmm.
Will they develop in their own character sets? Then will this be a vulnerability for C?
That's a very good one. I mean, in C, when you have a car type, okay, what's the values that it can have? I mean, is this unsigned or signed?
Implementation defined.
Right. Why is that? Because there were different character sets. Okay, the size of a byte. What's the size of a byte? Again?
At least 8 bits.
No,
defined.
implementation defined. There used to be computers with 4 bits. There used to be computers with 40, 42? 46, 48. Okay, 48, yeah. It makes sense when you think of it because reasons. Okay, so, and it doesn't say anything about ASCII because there were lots of other encodings. When I was in university, my professor was old school, so he always talked about EBCDIC. And we thought it was a funny name, but it really exists. EBCDIC, EBCDIC. ASCII, but different numbers, okay? Capital A is not 65, it's some other number. So what you're saying now is that we're back in time to where we have multiple encodings. Now, the other part of what you were saying is the fact that I can create std, colon, string, space, smiley. Okay, that's a valid variable name. And I actually used it once in a lecture. I had a slide. And before I did that, of course, I typed it and compiled it, and it compiled perfectly. So, yes, we can do all kinds of crazy things. Should we do that? I don't think so.
Well, I mentioned to a guy this morning, he said, well, C is about an install base of code. So there's not much maybe to be added. So but he said in JavaScript it's a much bigger problem because it's more exposed to these things.
JavaScript is...
But you know, you can just imagine a bad actor trying to inject some code in open source repository and at first sight it's just...
It looks legit. Yeah, you can do that with URLs, you know, in languages where, right now you can do that, you know, with zeros and capital O's that in some fonts look the same, or with semicolon that is also a question mark in Greek, right? But it's a different ASCII code, but it does look the same. So yeah, you can do that. Not only in C and C++, you can do that in URLs and stuff like that. Yeah. When they make me Tsar and I rule everything, this is one of the things I'm gonna take care of. Vote for me. Yeah.
Like we talked about the language, we talked about the rule sets, but the one thing which I think is missing is the tool chain which is going to compile it. Is it if that's not safe for C and C++ language? You're going to write a code which is sent, and then you expect the compiler or linker or whatever that's doing the mistake.
Yeah, so first of all, there is wall, dash wall, you know, W all, okay? Show me all the warnings. Don't ignore the warning of the assignment to a const and stuff like that, or all the other things. And if I'm talking about that, I have to mention where, of course, or treat all warnings as errors. Okay, I have to do that. That's the law. Should be, at least. And then, what's your name? Sorry? You. Jeroen. Okay, thank you. He said that new C++ has it built into the standards, so or in compilers, and I believe him. And then if you run static analysis tools as part of your CI/CD or even on your machine, then you can flag all these violations. Okay.
I mean, for example, if you look at, we can take any compiler, GCC, latest version. You go to bug tracker, how many bugs it has? Open bugs, which are not fixed.
You're talking about the compiler itself.
Yes, so like
being
you can
built.
make mistakes on the language, and there is no open source, like we're in open source summit. I know there are closed source, safe compiler.
Right.
Where is the open source, safe compiler, safe linker?
I don't know.
We do validate C compilers, all the flavors.
Okay.
But it's of course a commercial product.
Commercial, yeah. Exactly.
Commercial, right.
Yeah, I know. Like,
So he was looking for a C++, an open source alternative.
Yeah, exactly.
I'm not a compiler person, so I don't have a...
Just like, this is another problem to have, like, it's not just your language, it's just also the tool chain which is missing.
Yeah, yeah. So, yeah, we need to fill that gap as well. People, start writing open source compilers that are safer and more predictable, please. Maybe that should be the message of this.
And never rely on one compiler.
Like,
You know, too many people actually rely on a single compiler and it works on their box. And this is why they don't care about all these unpredictability, because their compiler is consistent with itself. And this is why they're still using, and this is a real case, 8-bit controller with an ancient version of GCC and Linux or whatever it was that operating, no, probably RTOS. And because they can't switch, they're stuck with their code and their compiler on top of their processor and operating system, and they can't move. That's it, rigid. And this is what I wanted to talk about, to prevent, okay? You should be able to port.
In certification, you don't trust a single compiler. You only trust a single compiler with given switches. And they're fully documented, and that's the certification just goes as far as the switches that you give to the compiler.
And also, like, people usually defer responsibilities. I know many commercial products where they get the safety certification by just getting from somebody else a safe compiler and just say it's not my responsibility. They have we use their product. If something goes wrong, it's their responsibility.
Yeah,
Just deferring
safety by proxy.
Yes.
Yeah, yeah, that's human, human behavior. Yeah. Last one, please. I mean, we can talk about that later. I mean, we can talk more, but I think the next people would like to get in. So, last one.
We talked about undecidable rules.
Yeah.
But what are the points of these rules? Because if an auditor comes and asks me, okay, prove me that you comply to this rule, how can I even prove it?
Okay, so I have a slide. No, I don't have a slide on that, but I can give you one, if you believe me. Floating point. Okay, if you ever use floating points, you know that there are these delicate and fragile creatures. And for example, you have infinite and minus infinite. You have none, not a number, and you don't have zero. You have two, positive 0 and negative 0. Now you compare two floating point numbers, and they're never the same, right? There's always, either it's plus 0 and minus 0, or it's stuff like they have this bit way back there that is not the same. So you always have to compare with a certain epsilon, right? So this is undecidable, because if I compare two floats, is this okay or not? The static analysis tool can't help me with that. Okay, I have to go to my specification and see that my epsilon, the tolerance is this or that. In the case of a non, it is the same as infinite or not. That's about the spec. And static analysis tool doesn't read the spec. So this specific rule, I don't remember the exact wording, but it's again, I think it uses the word appropriately, by the way. So this rule is undecidable.
Yeah, I understand the notion of undecidable rules, but what's the point then?
The point is that when you're messing with, messing with floating points, you have to go to the spec, because you don't have the safety net of the static analysis tool, and you should be aware of that.
Yeah.
And yeah, that's where, automatic stuff stops and people begin.
To enable nerds to complain about other nerds.
Yeah,
Yes, and job security. This was about security, so yeah, now job security. Thank you very much. If you have more questions, then I'm here.